When we say log or antilog, what we actually mean, suppose it is written 10 to the power 3. Suppose it is written 10 to the power 3. And 10 to the power 3 will be 1000. 1000 is equal to 10 to the power 3. This is something you already know. It means log of 1000 will be 3. Log of 1000 will be 3. Now you should have some idea about what is log. Log
So
is
the
nothing
power.
but, yeah.
So the power.
Yes, the power of 10.
Okay.
So if you are asked what is log of 12,000, sorry, 1250, it means when you will get 1250, if 10 to the power is x, what power of 10 will give you 1250? So you need to find that power of 10 which gives you 1250. In simple terms, that is log. Okay, so log 12, if 1250 is equal to 10 to the power x, then log of 1250 will be x. Simple. That is what we mean. 10 square is 100. 10 cube is 1000. The power 2 and 3 are the base 10 logarithms or common logs of 100 and 1000. That's what we have talked about. Okay, in simple terms. So in general, if you have a to the power b equals to c, then we say that log c base a is equal to b. That's what we said. 10 to the power 3 is 1000. So I said log 1000 is equal to 3 base 10. So it means I'm saying here, if I consider this one, log c, this one, which is 1000 here, base a is equal to b.
Sir,
Yes.
if there's specified base, then we normally take it as 10 only, right?
Yes, we will be taking base as 10, and the logarithm table which you will be given, or which you will be, I think I have received a message from few students that their teachers have been asked to bring their own logarithm table. Okay, so you need to take base 10 log with you table, not base e.
Okay, sir.
So this is something general knowledge. So the example you can remember that 1000 is equal to 10 to the power 3 and log 1000 will be 3. So from here you can understand the relationship. So it means if you are asked about any number, what is the log of that one, you need to find that power of 10 which will be equal to that number. So power here 3 of 10 will be equal to 1000. So log 1000 will be 3. How do you see it on the logarithmic table? That is something we will be talking about. So log tables are base 10. So a must always be 10. Here, this a is always 10. There is a relationship between log base 10 and log base e. So suppose you have been given log base e. So log of x base e is equal to 2.303 log of x base 10. So even if you want to calculate log base e, you can calculate. And that's why if you remember in few formulas, there is 2.303 in the formula of work and heat. If you know in reversible reactions, we use 2.303, it comes from there. How do you find? Okay, so to find the log on the log table, what we do, we identify the characteristic of the number whose natural log you want to find. So first of all, what is this characteristic? Okay. I will tell you what is. Okay. I'm explaining it with example. Suppose 15 lies between 10 and 100. You know it. 15 lies between 10 and 100. So its logarithm will be something between 1 and 2, because I need to find, this is 10. Okay. This is 100. This is 10 to the power 1. This is 10 to the power 2. So log 10, if I say log 10, it will be 1. If I say log 100, it will be 2. Okay. It means anywhere in between, say log 12 or log 93, anywhere between 10 and 100, it will be somewhere between these two numbers, 1 and 2, because log 10 is equal to 1 and log 100 is equal to 2. So log of any number in between will be 1 point something. 1 point something. Okay. It will always be 1 point something. It cannot be 1. It cannot be 2, because 10, if it is 1, that will be exactly log of 10. If it is 2, that will be exactly log of 100, somewhere in between. So when we say it is 1 point something, this 1 is characteristic. So whatever is we get before decimal is called characteristic, and whatever is after that is called mantissa. Okay. So whatever is written something is called mantissa. So suppose I get 1.234, that is log. Suppose this is called characteristic before decimal. This is called mantissa. Just you need to remember, because I will be referring to, otherwise it's not important. So log 10 will be 1. Log 100 will be 2. Log 15 will be somewhere between 1 and 2. Log 20 will be somewhere between 1 and 2. Log 80 will be somewhere between 1 and 2. But the moment you say log 100 something, 101, it will be 2 point something. Okay. It will go beyond this. So above 100, 2 point something. Above 1000, 3 point something. Above 10,000, 4 point something. Why? Because 10,000 will be 10 to the power 4. It means log 10,000 will be equal to 4. So this is an example. If you are asked to find the log of 15.29, sorry, 15.27, you will first consider the first 2 digits only. Always. Whether it is 15.27, whether it is 1.527, whether it is 152.7, you will just consider, when you are finding the log, you will consider just the digits of the given number, 1, 5, 2, 7. You don't bother initially. You don't bother about the decimal. Decimal will decide the characteristic, remember. Okay. Decimal decides characteristics. You can write, it is not written here. You can write in log, not anti-log, okay? In log characteristic, sorry, decimal decides characteristic of the result. So when you will find the log, decimal place will decide the characteristic, means what should be placed before decimal. This everything will tell you what is after decimal. Okay. So what we do, we slide the finger down to the appropriate row, and we will first consider only first 2 digits. And then how it looks like, I'm just going to switch it to log table. I hope you are able to see the log table
Yes.
here.
Yes, sir.
Okay, so this is how it looks. So on the left hand side, you have this column. Okay. You have this column. This is the 2 digits I am talking about. Okay, this is the 2 digits I am talking about. So 15 I talked about, and I have to find the log of 15.27. So first I will move to 15. Then there are 2 sets of columns, 9 columns here, and then mean differences 9 columns here. So 2 sets. So I will consider one by one. First, I will go to position 2, column 2, this column 2, and I will read in the same row. I will write the number, this number 1818. Then this 7, I will go in mean difference column, this 7 is here, and in the same row I will add this number 20 to it. So remember what I got. I got 1818, this one, and I got 20. I will add these two. So when I add these two, I will get 1838. 1818 plus 20 will give me 1838. So I'm going
Sir,
back.
can you explain again, sir? Sir, I just lost the voice.
Okay. What I'm saying that if we want to obtain the log of 15.27, so we will not talk about the decimal here. We will consider it as 1527. So when you are finding the log and you are referring to log table, you don't bother about the decimal. So 15, you will glide through or slide through the first column, very first column in the log table, and you will reach 15, the first 2 digits. Okay. I'm not saying it is before decimal. No, decimal we don't consider at all. First 2 digits, 15. Then there are 2 sets of columns, 9 columns here and 9 columns here. So first we will consider first columns and we will go to second column in first set. So second column in first set is this one. We will read in the same row, this value. Then there is 7, 1527. For 7, we will consider the second set of columns. So 7 here, we will move in the same row up to there, 20. So we got 2 values, 1818 and 20. We will add these two. When we add these two, we get 1838. And that's what you will be doing every time. Every time, this is what you will be doing in such cases. So you will get 15. You will go to 15. Then in second column, 1818. And then in next set of 9 columns, you will go to 7th column and 20, and you will add these two. You will get 1838. Now, you will see where the decimal is. After consulting the log table, you will consider the decimal. In the log table, you will never consider the decimal. Okay, log table. I am not talking about anti-log table. Okay, log table. So you have to obtain log of 15.27, and here you will see that what is the number before decimal. It is 15, and 15 is between which two tens, hundreds, thousands, etc. Because we know that log 10 is 1, log 100 is 2, and if it is 15 point something, it means it will be between 10 and 100. Its answer should be something 1 point something. Okay, log. This is the number, and this is the log of that number base 10. So the log should be 1 point something because it has to be in between the 10 and 100 logs. 10's log is 1, 100's log is 2. So now it is very easy.
So can we have a log of a number that does not have any decimal place?
Yes. Then I'm coming to that. Okay, if it does not have any decimal place, it means the decimal place is in the last.
Okay.
Decimal place is after the fourth digit in that case, if it doesn't have any decimal. After finding this one, you add the characteristic. So that's why I told you that statement. Okay, that the decimal decides the characteristic. So because it will be between 1 and 2, it will be 1 point something. So characteristic will be 1. That is the characteristic. This part is called mantissa. So characteristic we decide from the decimal point. It means the log of this one will be 1 point, whatever we obtained from log table, 1838. And these are the steps you will be following for every log. Now, if you have understood it, I am asking a question just to check whether you have got the point or not. Suppose you are asked to write the log of 152.7 base 10. What will be its value? Write in the chat box. Write in the chat box the log of 152.7. Somewhere, think again. Karthike, yes. Arjun, yes. Karthike, however, there is some typo. I thought you want to say 38 instead of 28, but I know.
Yes, sir. Yes, sir.
Think again. Samad, you are close. Right, complete answer. Remember, I said decimal place decides characteristic, and decimal place here means the number is 152. 152 is in between what? Is between 10 and 100 or between 100 and 1000?
10 and 100, sir.
152 is between 10 and 100. Are you sure?
Sir, 100 and 1000.
100 and 1000. It is greater than 100, less than 1000.
Sir,
So
can you please look at my answer?
Arima, no. Lemuel, no. Devyansh, yes. Okay. So understand what I am saying. When you calculate the log, you don't bother about the decimal. Okay. So it means you will get the same thing. You will get 1838. There will be no change in it. 1838. Because you don't consider decimal. Whatever you got in previous case, the same thing. But now you will consider 152 is in between what? If I consider log of 100 and 1000, 152 is between 100 and 1000. Okay, these are the numbers. So log of these ones, log of 100 will be 2. Log of 100,000 will be 3 because it is 10 power 3. It means log of 152 point something will be 2 point something. This something you have already calculated. From log table, you get something. Okay, from log table, you get something. From decimal place, you get characteristic. So log table, I'm writing it again. Log table gives us mantissa. Decimal place gives us characteristic. So log table has given us mantissa. But what should be the characteristic? Means this something, point something, we know. The characteristic we don't know. That we will get from here. 152 is between 100 and 1000. Log of 100 is 2, log of 1000 is 3. We know it means the number will be 2 point something. So it means we will have 2 here. The log will be 2 point something. Something we have already obtained. Yes, Pratyush, that's what I am saying. Log table will give you just the mantissa part. Characteristic will change according to the decimal place.
Okay, sir.
So if someone asked that if the number would have been without any decimal, so it means we are talking about log of 1527. It does not have any decimal. Again, the mantissa part will be same because we have same digits 1527. We need to just get the characteristic, and for characteristic now we need to see this number is in between 1000 and 10,000.
3.
Yes. So it is greater than 1000, less than 10,000. And we know that log of 1000 is 3, log of 10,000 will be 4. It means log of 1527 will be 3 point something. This mantissa something we have already obtained. It will be 3 here. Okay, so we just see that which particular parts it is between, we get the characteristic according to that. Now finding the antilog. Just I'm giving you one more example before I move forward. Just a second. Suppose you are asked about how to calculate the log of
Sir,
yes.
so do we need to always write 3 points mantissa, or we have to calculate the point also?
Come again, Vedant. I
Do
think
we
you need
need
to
to
change your
always,
headphone or mic doesn't work properly.
sir, is it fine now?
Yeah. So yes, I'm trying to understand what you are saying. Say again.
Sir, I'm saying that is it compulsory to write 3-point mantissa, or we have to calculate the value also?
What I didn't get you. Why you need to
Sir,
calculate something?
sir, he's saying that it is necessary to write the 3 point something or a 3 point mantissa. We cannot
No, no,
directly
no,
write
no,
the
no.
value.
That is just to make you understand. You just need to write the value. Nothing. You will just see the log table and you will say that log 15.27 will be 1.1838. That's it.
Okay, sir.
According to log table. Here I am explaining. That's why I am writing so that you can retain, you can recall it. So now suppose you want to calculate the log of something. Say I'm just saying, for example, calculate the log of 213.4. 213.4. So I won't bother about point. Okay, I will just consider 2, 1, 3, 4. Okay. So I will move to 21st row. So 21st row here, where 21 is written, it does not mean 21st row, where 21 is written. Okay. Then in the first set, I will go to third column. So this is the third column, and I will mark in the same row the value pertaining to third column. Then in the second set, I will go to fourth column. This is the fourth column here. Okay. And then I will move down to the same row. I will write 8. And then I will add these two. 3284 and 8. So I will get 3292. Okay.
2.3292.
Yes, good. 3292 I got. So it means I got the mantissa part. Now I will see where is the decimal. Before decimal, I have 3. So 213 is between 100 and 1000. Between 100 and 1000 means between 2 and 3, 10 to the power 2, and between 10 to the power 3, 1000. It means it will be 2 point something. So answer will be 2.3292.
Yes. Sir,
Yes.
Excuse me, sir.
Sir,
So
what?
can we round off the values according to our requirements?
You can sometimes, and I suggest that if it is MCQ type question and you are given log tables, you can easily round off. But normally round off only the last digit. Okay, not beyond that.
And sir, the log tables, sir, you said that you have to take it with you. Like, sir, you have to take this
I
print
didn't
out.
say. I didn't say. I said that few students have sent me a message that their school has asked them to bring their own logarithmic tables. So if only your school has asked.
Okay, sir. Okay, sir. Otherwise, you'll be provided.
Normally it is provided. 99% cases it is provided. I think rarely teachers can ask. Otherwise, I have not seen that teachers should be asking to bring log table. The reason is that the students might not refer to the correct log table. Standard log tables are there, which should be provided by schools. They should not be asking students to bring their own log tables.
Okay. Thank you, sir.
So once it's done, now we should move to antilog. Okay. Antilog is opposite of that. So it is actually you have to find 10 to the power of that. So suppose I say what is antilog of 2? Antilog of 2. It means I am saying what is 10 to the power 2. Antilog is very easy, but to understand. But suppose I ask you to calculate antilog of 2.371. No, it's a problem. It will be 10 to the power 2.371, which you can't calculate easily. 10 to the power 2, it was very easy, 100. But it's not easy to calculate 10 to the power 2.371. So that's why we have antilog tables as well. And what's the way? Similar way there also, but because decimal point, that is something we need to decide. I will be explaining. Okay. So it is simple. Okay. So we need to use antilog. Antilog means we need to find 10 to the power of that. So first, write down the characteristic. This is the number before the decimal point. So understand it as opposite of log. In log, what you got? In log, suppose it was log of 15.27, and it was just a second. It was equal to 1.1838. Okay, so it means this one decided that decimal place will be here, opposite of that. This one decided because 10 to the power 1, this number is between what? This number is between 1 and 2. So 10 to the power 1 is 10, 10 to the power 2 is 100. I'm talking about opposite of log now. Okay. So means if characteristic is 1, it is 10. If characteristic is 2, it is 100. But this number is between 1 and 2. It means the log means anti-log of 1.1838, that is log. Number should be between 10 and 100. And between 10 and 100, you will consider 1527, where we should place decimal so that it is between 10 and 100. I can't place decimal here because then it will be between 1 and 10. I can't place decimal here because it will be between 100 and 1000. the number 15.27 will be between 10 and 100. So this characteristic actually will tell us where the decimal has to be placed, opposite of log. How we do that? Suppose you are asked to calculate the log of 2.8699. So you will consider only the mantissa part, because this is what you got after taking log. You remember that when we took log, actually log table told us only the mantissa part. So here we will consider the mantissa part to get the antilog, and then characteristic will decide where the decimal should be placed. Their decimal decided in log, decimal decided what will be the characteristic. Here characteristic will decide back where the decimal should be placed. And the method is exactly same. If you could understood this, the method is exactly same. Now what we do? We consider the first two digits again. So first two digits are 86. Remember, we are considering only the mantissa. Characteristic will decide the decimal. We will not consider in the antilog table, only this part. This part is exactly what we got from log. Okay. So we will move to 0.86. So 0.86 we move to. After that, again, it is simple. Then we have 9. And then again, we have 9 here in this case. So both columns are 9. So once we have achieved that one, we will then move to 9th column of the first set. And we will note down the value similar to the log table, what we did there. Then again, we will move to next set of columns and 9 there. So here eventually both are 9. So 9th column again here, and we will note down that column as well.
Repeat again.
So what is the number? The number is something characteristic which we don't consider while calculating the antilog. 8699. So first we will go to 0.86. Then we will move to 9th column of first set of columns. Then we will move to 9th column of the second set of columns. That's what we have done. First we move to the 0.86 in the very first column. Then we will move from here to right side up to 9th column of the first set. So 9th column we see, and in the same row we will note down this value. So it means we have covered from till here, we have covered 0.869. This is something what we have covered. 0.869. Is this clear what I am saying?
Yes, sir.
Okay.
Yes.
To cover the next 9 now, this one, we have to move again in the next set of columns, these columns here. So we again move to next set of columns, and 9th column, there we note at 15. So we got again two values. First value we got as 7396, which we have noted down. And then in the next set of columns, 9th column gave us 15. So these two numbers we add again. Process is very simple. Those two numbers we added, we got 7411. 7411. Remember, the number was 2.8699. This was the number. And we said that after finding this will decide the decimal, and 2 point something. Okay, if it would have been exactly 2, antilog would have been 100. If it would have been exactly 3, antilog would have been 1000. So it means it will be, the number will be somewhere between 100 and 1000. If it is somewhere between 100 and 1000, tell me where the decimal should be placed in this number. Here characteristic will decide the decimal place now.
Sir, after 741.
Yes, correct. Yes, Arjun.
Yes.
So the number, if you place the decimal, only 741.1 will give you the answer. This is between 100 and 1000, not 74.11, not 7.411, not 7411. So in log, sorry, in log, decimal place decides characteristic. In anti-log, characteristic decides where the decimal place will be in the answer. Any confusion? Let me know. Now I'm just
Sir,
doing,
can you do it once again, please?
I'm explaining with another example, okay? I'm explaining it with another example. Just let me open the anti-log table. Probably I have closed. Okay, can you see anti-log table here?
Yes, sir.
Is anti-log table
Yes, sir.
visible?
Yes,
Okay.
sir.
So suppose you are asked to calculate the anti-log of 2 point, say 1 point, okay, 1.5 to 4 and 7. Say this is the number. Okay. So remember, anti-log you will consider only mantissa, because when you calculate log table gives you mantissa. Okay, characteristic is decided by the decimal. So you don't get characteristic from the log table. You get only mantissa. So in anti-logarithmic table, you will consider only mantissa part. So first you will go to the 0.52 column. So 0.52 column, if you see, is 0.52 column, we will move down. Okay, 0.52. So we will move to 0.52 column. This is 0.52 column. 0.52 column, we have moved here. Then 0.5247. So I will move to fourth column. Okay. And remember, I'm going back at the top just to let you know that which is the first column. First column is actually 0. So don't consider this one as, sometimes in hurry, if you are say, here, you consider this one as 1. No, this one is not 1. Okay. This one is actually 0. So you will go to 4. This one. In first set, that is blue set. And in the right set, then you will go to 7. Again 0, 1, 2, 3, 4, 5, 6, 7. So here, if you see, I'm going back again because here it is different. Okay. Just going top to. Okay. Here it starts with 1. Because if it is 0, you don't consider that. You don't bother about that. Okay. There is no number for that if it is 0. Okay. So that's why you in second, it starts from first, and 4 you have already gone. Now you need to go to 7 in second set. that is this particular column. So 7, here it is 5. Now you will add these two numbers, 3342 and 5. So you will get 3347. You will get 3347. So 3347, you will write 3, 3, 4, 7. That's what you got. Then you will see what was the characteristic. What was the characteristic? Okay. So if I go forward, it is 1. Characteristic was 1. So I will see where the decimal place should be. Tell me.
So 33.47.
Yes, correct. So if it is 1, it means 10 to the power 1 is 10. And next one is 10 to the power 200. So it should be between 10 and 100. That is
33.47.
Now just have printout of log table, or you can buy log table from the shop and do a lot of practice before you appear in exam.
Sir, could you please show the number once? Actually, I left the meeting due to voice issue.
Anti-log of 1.5247.
Sir, I thought it should be 3.347 because of 1, sir, because it would come from 10. Sir, am I wrong here?
Yes, because if it is 1, it will be 10. If it is 1 point something, it will be greater than 10. And it is
Okay,
greater
okay,
than
sir.
1.1. 1.5247 is greater than 1.
Yes, yes, I got it.
Excuse me, sir.
Yes, Vita.
Sir, like up to what value should we have the log and the anti-log table?
That is basically the rule is that log you will be asked to calculate up to 4 digits. So the number will be maximum up to 4 digits. Okay. And otherwise you will have to do approximation. For example, if it is not 4 digit, you will write it that something multiplied by 10, for example. Okay. And antilog, again, the similar way, antilog can be any number up to, after decimal, there will be 4 digits. Okay, so there will be characteristics, and if you are asked to calculate antilog, you will consider only 4 digits, otherwise you will round off.